Hey everyone, and welcome to this explainer. Okay, so if you've ever found yourself just staring at those little bars on your phone, waiting for a video to buffer, and kind of wondering what is actually happening behind the scenes to dictate your internet speed, well, you are in the exact right place. Today, we're going to demystify the actual math behind mobile internet speeds. And the best part? We're not using some dry, boring textbook to do it. No, we've got something way cooler. The actual handwritten field notes of a working telecom engineer. We are literally going to decode their personal cheat sheet to uncover the anatomy of LTE speed. It's a question that honestly feels like it should have some highly complex, almost magical answer, right? Like there's some wizardry happening up in those cell towers. But the reality is actually far more structured. Okay, let's dive right into this, because the way your 4G LTE speed is calculated really boils down to one highly specific, highly elegant mathematical formula. And it's a formula used by engineers out in the field every single day to troubleshoot and optimize your connection. So, to get a grip on all this, here is our roadmap for today. It's like a giant puzzle, and we're going to build it piece by piece. First up, unlocking LTE speed. Second, the core formula revealed. Third, the unchanging constants. Fourth, the dynamic variables. And finally, number 5, calculating final megabits. All right, let's kick things off with section 1, unlocking LTE speed. So before we get to the math, let's establish the raw, real-world context of what we're looking at here. This isn't some polished corporate training slide deck. This is a genuinely raw, authentic look inside a working field engineer's toolkit. These handwritten notes, they're a practical guide used by pros on the ground. When you call up your provider to complain about incredibly slow internet, the engineers investigating that specific pain point are relying on the exact principles scribbled on these pages. This is literally telecom engineering in its most practical, applied form. Moving right along to section 2, the core formula revealed. Okay, think of this equation as the ultimate cheat sheet that governs mobile networks all across the globe. Here it is in all its glory. Resource blocks, times 12, times 7, times MIMO, times modulation, times 2000, all divided by 10 to the power of 6. Now, I know what you might be thinking. Looking at that giant string of acronyms and numbers all smashed together can seem pretty intimidating at first glance. But honestly, don't sweat it. We're going to meticulously dissect this thing piece by piece so it makes total sense. By the end of this explainer, you're going to know exactly what every single variable in this equation actually does. Actually, the absolute best way to understand this formula is to use a pipeline analogy, because the formula itself is cleanly split right down the middle into 2 distinct categories. On one side, we have the constants. These are your fixed network foundations. Think of them as the rigid physical dimensions of a water pipe, like the pipe's diameter and length. They absolutely do not change. On the other side, we've got the variables. These are the dynamic network conditions that change based on your signal strength and your specific phone. Going back to our analogy, these variables act as the water pressure and the volume of water actively flowing through that pipe. That brings us to section 3, the unchanging constants. Let's shift our focus entirely to that first half of the split. If we zoom into another page of the engineer's notebook, we can see exactly how the network physically structures data. It's fascinating. The notes explicitly detail the time domain, which is set at 1 millisecond. To send data, the signal splits the carrier frequency into a bunch of smaller carriers. Specifically, it uses exactly 12 subcarriers. And then, within each of those 12 subcarriers, the notes specify that they contain exactly 7 symbols. These are the microscopic, fundamental building blocks of your wireless connection. So pulling directly from those notes, our fixed foundations, the exact dimensions of our data pipe, are those 12 subcarriers and 7 symbols. But wait, what about that massive 2000 number we saw in the master formula? Well, the engineer's notebook explains this so brilliantly. The data is sent out in tiny time slots of 0.5 milliseconds. To figure out how many of those time slots happen in a single 1-second window, you just divide 1 by 0.5. And boom, that gives you exactly 2000 time slots per second. So those numbers, 12, 7, and 2000, they will always remain the same in this LTE calculation. They are the unchanging pipe. All right, jumping into section 4, the dynamic variables. So now that we've got our pipe built, let's look at the elements that actively change based on your specific network conditions. Things like how far you are from the tower or the tech packed inside your actual phone. Now, what's really interesting about this slide is seeing how the engineer manually tracks these shifting conditions. we can see notes on resource blocks, or RB, which the engineer documents as depending directly on your available bandwidth. Then there's MIMO, which stands for multiple input, multiple output. And finally, modulation. These three values, they're the water pressure in our pipe. When you get a better signal, these values just crank up and your data flows way faster. And this perfectly illustrates the real-world application we're looking at here. Right in the middle of tracking antenna setups, the engineer writes out this incredibly practical troubleshooting question, complete with authentic bilingual Arabic shorthand. They write, how to know if there are cross MIMO or not, followed by the Arabic, إزاي أعرف cross MIMO. إزاي أعرف literally translates to how to know. It's just a wonderful reminder that, hey, this isn't just theoretical math on a chalkboard. This is a very real, practical toolkit for a technician out there trying to figure out why a specific cell tower isn't pushing out the data speeds it's supposed to. So let's look a little closer at one of those powerful variables, the modulation code scheme, or MCS. According to the notes, modulation is essentially how tightly you can pack data bits into a single symbol. If your signal is just, okay, the network uses something called QPSK, which packs 2 bits per symbol. But as your radio conditions get better, the network upgrades you. It jumps to 16 QAM for 4 bits, 64 QAM for 6 bits, all the way up to 256 QAM, which crams a massive 8 bits into every single symbol. So modulation acts as the data density in our pipeline. The cleaner your signal, the denser the data. The absolutely crucial point here is how all these variables interact with each other. First, your resource blocks increase depending on the total bandwidth available from the tower. Second, your MIMO scales up by multiplying the physical antennas in use. Maybe you jump from a single antenna to 2 or even 4. And third, your modulation packs that data tighter and tighter, scaling from 2 up to 8 bits per symbol. Because these are all multiplied together in our core formula, even a really slight improvement in your signal can just drastically increase the flow of data through our fixed pipe. It's a compounding effect. And finally, Section 5, calculating final megabits. Okay, we've built the pipe, we've turned up the water pressure, and now we're bringing the two halves of our equation back together. Let's revisit the very end of that master formula. After you multiply the resource blocks, the 12 subcarriers, the 7 symbols, the MIMO antennas, the modulation bits, and those 2,000 time slots, you are left with this massive, totally unwieldy number. That huge number represents your raw bits per second. But obviously, we don't measure our mobile plans in single bits. So the final step in the engineer's formula is dividing that massive product by 10 to the power of 6, which is 1 million. That one simple division converts all those raw bits into the final Mbps, or megabits per second, that you actually see pop up on your screen when you run a speed test. And there you have it. That is the true anatomy of your mobile speed, pulled straight from an engineer's real-world notebook. By understanding this delicate balance of fixed constants and multiplying variables, you can see exactly why just, walking a few feet down the street can radically change your download speed. But I do want to leave you with one final thought to ponder today. If this intricate, carefully balanced equation is what governs 4G LTE, how is this exact mathematical framework going to adapt, or maybe entirely break down, when pushed to the extreme limits and massive bandwidths of 5G networks? It really makes you wonder what the next page of this engineer's notebook is going to look like. Thank you so much for joining me on this explainer, and keep learning.